Hello everyone, today in this video I will discuss about how to answer the question 3A and B for KMK 2022-23 set 3. So let's move on to the question A. It stated that the molecule given iodine trifluoride, iodine tetrafluoride minus and iodine tetrafluoride plus. First, draw and name the molecular shape, and second, predict the type of hybridization and deduce its molecular polarity. So let's move on to the first thing that it asked is to draw and name the molecular shape. So for me, the easiest way to answer this question is to first to do the Lewis structure of the given molecule. So move on to the iodine trifluoride. So for the Lewis structure iodine trifluoride, first of all you need to do the valence electron. To calculate the valence electron, we say that I only have 7 valence and fluorine has 7 times 3, so we got 28 electron. So we just do a normal Lewis structure with I as a central atom and 3 branches of a fluorine atom. So after we do the Lewis structure, we need to categorize the molecule based on the classes. So when we see the Lewis structure, we know that we can state that it's a B3E2 class because it got 3 branch and 2 lone pair electron. So based on these classes, we can draw its molecular shape like this, and it's called a T shape. And for the for the type of hybridization, we can state it that based on the electron pair, we got a 3 branch and 2 lone pair given 5 electron pair, and we got the sp3d type of hybridization. And it is a polar molecule because it's a symmetry and we can cancel out the bond. So that's all for the first molecule, iodine trifluoride. For the molecular shape, molecular name, type of hybridization is sp3d, and it is a polar molecule. So moving on to the second molecule, which is iodine tetrafluoride plus. So first of all, it is the same as the first molecule. We need to draw its Lewis structure first. So calculate the valence electron. The I got 7 valence electron, but because of it because it's the plus, we need to minus 1 electron. So we minus 1 here, and fluorine have 4, so 7 times 4, we got a 34 electron. So next we just drew the normal Lewis structure. We got I as central atom and 4 branch of fluorine atom, and don't forget to draw the bracket for the plus ion because it's an ion. So after we draw the Lewis structure, we need to recognize the classes. So the classes is AB4E because it got 4 branches and 1 lone pair. So moving on to the molecular shape, we draw it like this. We draw it in a seesaw shape, which is based on the classes AB4E here. So we need to recognize the type of hybridization, which is sp3d, same as the iodine trifluoride because it got 5 electron pair, which is it got 4 branch and 1 lone pair, which means it got 5 electron pair. And lastly, it's a polar molecule because it's a symmetry, and we can cancel out of each of the bond. So the one thing that I want to say is the differences between iodine trifluoride and iodine tetrafluoride here, because iodine tetrafluoride is an ion, so we need to make sure that we doesn't left behind the bracket for the ion itself. So lastly, we move on to the last molecule, which is iodine tetrafluoride minus. So same, first we need to draw the Lewis structures for us to can see the molecular geometry shape better. First we can find the valence electron. I got 7 because we need to plus 1 electron here because it is a minus ion, so we need to plus 1 here, plus 1 electron, and fluorine have 7, so 7 times 4, we got 36 electron. So next we draw the Lewis structure. normal, RIS and central atom, and 4 branch of fluorine atom. And don't forget the bracket and the minus here. And based on the structure, we can state the class, which is A, B, 4, E2, A, B, 4 because we got 4 branch, and 2 with E2 because we got E2 lone pair at the central atom. So based on the class that we have made a conclusion based on the structure here. From the class we can draw the molecular shape, draw the molecular shape here, and based on the shape of the square planar, like this shape, we got a branch like here. And don't forget to draw the minus bracket out here. And we need to predict the type of hybridization based on our electron pair. So we got 4 branch and 2 lone pair electron etc. atom, which indicate it has 6 electron pair because 4 branch here plus 2 lone pair etc. atom, and we got 6 electron pair, which indicate it's sp3d2, which is the maximum electron pair that we learn in this syllabus. So it is non-polar molecule because it is minus atom, and we cannot, it is not asymmetric, it is a asymmetrical molecule, and we cannot cancel out the bond between them. I think that's all for the question 3a. So the conclusion for this question is first, we need to draw the Lewis structure first because it makes us easier to understand to draw its molecular geometry, so that we do not do a mistake on to draw another shape. First, calculate the valence electron, draw the molecular geometry, draw the molecular shape, determine the name of the shape, and predict type of hybridization, and lastly stated whether it's a polar or non-polar molecule. So I think that's all for question 3a. We move on to the question 3b. So for the next question, question 3b, it stated that the valence orbital of N in the nitrogen trifluoride and FT molecules are hybridized, and as the hybridized orbital to form bond in NF3 molecules. Name the molecular geometry of nitrogen fluoride trifluoride. Describe the hybridization process of nitrogen trifluoride. So first it stated that it wants us to state the type of hybridization, and we need to label the overlapping orbital showing all. We need to describe the hybridization of nitrogen trifluoride. So when the question asks us to describe the hybridization, for me, as usual, we need to go back and start from the basic, which is draw is Lewis structure. So as I teach you on how to draw the Lewis structure, first draw the valence electron, determine the valence electron, the 5 valence electron for the nitrogen, and the fluorine have 7, so 7 times 3 we got 26 electron. So just draw the Lewis structure as normal. We got nitrogen and a central atom and 3 branch of a fluorine atom. That's all of the octet arrangement. So moving on, when we draw our Lewis structure, we can conclude the class of this molecule. We say the class is AB3 because it got A, 3 branches and 1 lone pair. So the molecular shape for this class is a trigonal pyramidal, and the valence electron configuration of N, as we know N have 5 valence electron, which indicate a 2s2 and 2p3. 2 plus 3 we got 5, so it is correct that nitrogen have valence electron. So to describe the hybridization process, first we need to draw it at the ground state. The ground state, as we know, it have 2s2 and 2p3 configuration. So we draw a 2s2 and 2p3 right here. S have only 1 orbital and 2p have 3 terminal. So we draw it like this because it have 5 valence electrons. And when we look at this, we need to find a 3 unpaired electron because we want to do a 3 sigma bond here. So we need, when we look at the ground state of the N atom, it already have 3 unpaired electrons, so we do not need to promote it and to an excited state. when you see here it have enough 3 unpaired electron to do 3 sigma bond with the fluoride atom, we can just keep it to the hybrid state. At the hybrid state, we just combine all of these electron together, and we got a sp3 type of hybridization, because it have 1 2 3 4, which indicate sp3, and have 4 terminal atom. So lastly, we draw is the molecular shape which is n, which is trigonal pyramidal shape, n at the middle with lone pair and 3 branches of fluorine atom. So I think that's all on how to solve this B question. So when the question asks you to describe the hybridization of whatever molecule, first you need to draw its Lewis structure so you can get the class of the molecule, and determine the molecular shape based on the classes that you have concluded, and draw the valence electron configuration, which is n have 2s2 and 2p3, and 2s2 here and 2p3, and we only have 3 unpaired electron to form 3 sigma bond here, one here, one here, and one here, and which indicate that we do not need to go to the excited state, just keep it to the hybrid state, and we can get the sp3 type of hybridization here. And lastly, we draw our molecular geometry here based on the trigonal pyramidal. I think that's all from me. Thank you very much for watching, and I hope you understand and thrive in chemistry subject.